Okay, and rotations, these, at least for me, they're a little different. They're a little harder to picture, maybe a little more difficult to double check after you've drawn it, whether or not it looks the way it should. You should still, it's a rigid transformation, you should still have the same size and shape, but because of the rotation, they're just a little harder to picture. So that's at least how I feel. If you feel that way as you're doing it, just know that you're not alone in that feeling. So a rotation could also be described, there isn't a blank for it, but it could be described as a turn. So rotating, you're turning the object a certain amount. This is a transformation. That moves every point of the pre-image through a specified angle and direction about a fixed point called the center of rotation. So it moves every point of the pre-image through a specified angle and direction about a fixed point called the center of rotation. If the point being rotated is the center of rotation, which sometimes you might have a figure where it's being rotated, say, about the origin and one of your points is on the origin, then the image and pre-image are the same point. So in that case, that specific point will not move. But if the point being rotated is not the center of rotation, then the image and pre-image are the same distance from the center of rotation, and the measure of the angle of rotation formed by the pre-image, center of rotation, and image points is x, some x degrees, whatever that might be. And that's going to be given in the problem what angle you are rotating about, or how much you're rotating it. So we are just focusing on rotations in the coordinate plane. So we are only rotating a point either 90, 180, or 270 degrees. And we are rotating these counterclockwise. So if you think the direction that a clock goes, which I have to do it backwards to show you guys. So counterclockwise is the other way. So it's like you're rotating it left, if you want to think of it that way. So counterclockwise is the rotation direction. But there is a procedure with the ordered pairs that you can use for the rotation based on the angle of rotation. So if you are rotating 90 degrees, then how we're going to work through these is we're going to get the points of the image. So we're going to find, like if you have triangle ABC, we're going to find A prime, B prime, C prime first, and then plot them using these procedures. So 90 degrees, you multiply your y coordinate by -1, so it becomes the opposite, and then you interchange or you switch the x and the y coordinates. So for 90 degrees, if you start out with an ordered pair x, y, it's going to change the following. I multiply y by -1, so it becomes -y, and then I switch my coordinates. So I have -y and then x. So that's what your point will become for all of your vertices, and then you can graph your image. If you are rotating 180 degrees, you will just multiply both coordinates by -1. They both become the opposite when you're rotating at 180. So if you start with x, y as your pre-image, your image will be -x, -y. And then if you're rotating 270, you multiply the x coordinate by -1, and then you switch the x and the y coordinates. So if you start with x, y, I multiply x by -1, so it's -x, and then I switch them, so it's +y and then -x. Okay, so our first example, we are taking parallelogram WXYZ with the following vertices. We are going to graph that parallelogram and its image after a rotation of 270 degrees about the origin. And so I just have as a reminder here, so these directions, the procedure for 270, you take your x coordinates, multiply by -1, and then you change the x and the y coordinates. So we can come up with our coordinates of our image. So W, that point was -2, 4. So if I multiply the x by -1, that becomes +2, and then I switch them. So it's 4, 2. So for x, I would multiply the x coordinate by -1, so it's -3, and then I switch them, so x prime is 6, comma, -3. For y, multiply 5 by -1, so -5, switch them, so y prime is 2, comma, -5. And then z is 0, 0. So if I multiply 0 by -1, it's still 0. Switch them, I still have 0 in both places. And then this also is, since we're rotating about the origin, so z is the origin, so that point, like we specified above, isn't going to move. Z and z prime are going to be the same point. So I'm going to plot my original 4 points so I can see this parallelogram. And again, make sure you label. Another way to think of these rotations, I'll plot the other 4 points and rotate it, but this is kind of thinking of a circle. So if you take a point, if you rotate it all the way around, like if I rotated point X all the way back to itself, which would then create a circle, how many degrees is that? 360. So if you had to graph an image after rotation of 360, realize the pre-image and the image are going to be the exact same in the exact same place. So if you rotate 90 degrees, you are rotating a quarter of the way around a circle. If you rotate 180, you are rotating around a semicircle. You're rotating half of the way around a circle. And if you rotate 270, you're rotating 3/4 of the way around a circle. So to kind of put it in perspective, where it ends up, or thinking about where it should end up. So I'm going to plot my other points and label them. And then z and z prime are the same points. So this is where it ends up. And like I said, it's a little bit harder to picture if you're thinking, is that right? But knowing if I take this and I'm rotating it around z, so z is staying where it is, but as I take w, I'm rotating it 3/4 of the way around a circle. So see where that ends up, see where x ends up, again, 3/4 of the way around a circle there. With that center being the origin, see where y ends up, and then z stays where it is. But that's your rotation. So it's going to be practicing those 3 procedures. So how does the coordinate change? And then being able to know those, using them enough so that you know them. Any questions on that? Okay. I am going to skip this first one here. I'm actually 1 and 2 are both a rotation of 90. I'm going to do 2 just because it's a little bit quicker since it's a triangle versus a trapezoid. So we have triangle LMN has the following vertices. We're rotating at 90 degrees, and these are all rotated about the origin. So when you're thinking of, like, if you were making a circle, the center is the origin. So if I plot my 3 points, Check your triangle, check that that's graphed correctly. And I'm rotating it 90, so I'm going to figure out what my 3 points of my image are first. You see some of you flipping to look at that procedure again. So for 90 degrees, here you multiply the y coordinate by -1 and switch them. So for L, the y coordinate was -1, it would now be +1, and then I switch them, so L prime is +1, -1. For M, the y coordinate was -4, it's now +4, and then I switch the coordinates, so it's +4, 0. And for N, the y coordinate will now be +2, and they'll switch, so +2, -6. And thinking too about where it should end up. So right now, kind of looking, we're in the third quadrant. So if it's rotated 90, that's a quarter of the circle. So it should end up in the third quadrant as you're graphing this, kind of making sure it ends up approximately where it should be. If it was rotated 180, it'd be rotated kind of 2 quadrants, and then 270 would be over here. If I plot these 3 points, and label them. This is your rotated triangle. Questions on that one? Okay, and then we'll do 3 together, rotating that triangle 180 degrees. And I'll plot my 3 points first. And for rotating 180 degrees, you just make both coordinates from both original coordinates the opposite. They're both multiplied by -1, they don't switch. So if I had -3, +5, A prime is now +3, -5. For B, it was 0, +2. 0 will still be 0, but now it'll be -2. And then C was -5, +1 will now be +5, -1. I'm thinking if it is rotated halfway around a circle that would be created, again, it sometimes is helpful to think about which quadrant should it end up in, so it makes sense that it's in quadrant 4. If it started in quadrant 2, it's passing through one quadrant and landing in another. Okay, so if you haven't already, because I know some of you are working ahead, why don't you go ahead and do number 4? Actually, I might just give you a little bit of time, do number 4, but then while you're waiting, you can also, the rest of the examples are just review. So 5 through 8 are just looking at that figure and saying, what is the name of the transformation? So is it a reflection, translation, or rotation to get from tree A to the other trees it lists? And then 9 through 11 are just naming the coordinate based on the reflection. And then we'll just go through these. We are going to go through these. I do want you to finish the examples. I'm just leaving the assignment, so if you are done waiting, you have to. And the last three, you are actually saying what the new coordinate is, so what the image is. You don't just graph it, but say what it Okay, let's take a look at these. I know some of you might be finishing up the number 4, graphing it, but let's see here. I'm going to show that, and then we'll discuss the other ones. So here you can check 4. So check that my image is in blue. Your final image for number 4 should be in blue. So still have your note sheets out, guys, because I wanted to talk through the last ones too. And then you can check your coordinates if yours doesn't look right. Because some of you were still working, so I'm not sure if you had it fully done when I walked by. But you are changing the x or multiplying the x coordinate by -1 and then switching the coordinates. Any questions on that? Okay, and then I don't have these just written in because I wanted to ask you guys about them. So this is just naming the transformation again. Is it a reflection, translation, rotation that maps tree A onto these 4 trees that it lists? So what transformation did you say maps A onto B? All right, guys, put the assignments aside for right now. I want your attention up here because there's multiple answers to these. What maps tree A onto B? Okay, could be a reflection. I would also accept translation. You could say, well, it's just moved over. You could also say there's a line right here that could have reflected it. So reflection or translation would work. What about for tree C? That would be a reflection. Tree D maps tree A onto tree D. Rotation. What would the angle of rotation be? That would be a rotation. Not that you'd have to say that, but this would be your point of rotation right here. And that would be a rotation halfway around a circle, rotation of 180. And then what about map or tree A to tree E? Oh, what? Could be a translation. What else could you say it could be? What if I had a line drawn right here? It could be a reflection over that line. So I would accept, just like for number 5, I would accept reflection or translation for E. For number 8, to tree E. And then you can check your points for 9, 10, and 11. So for 9, M prime, if you reflect, and you could have used the graph to help, but actually naming the points. So this should be +4, -2. N prime should be -5, +1. And then S prime, remember if you reflect over y equals x, you're switching the coordinates, so -2, 3 would be that ordered pair.